Section 3.2 is on logarithmic functions, and we say that the inverse function of the exponential function with a base b is called the logarithmic function with base b. Okay, by definition, a logarithmic function is simply the inverse of an exponential function. Okay, this says definition of logarithmic function: y equals log base b of x is equivalent to b raised to the power of y equal to x. Okay, these two statements are equivalent. Okay, they mean the same thing. And logarithmic function is simply just another way that you can write an exponential function. Okay, you can have what we call a logarithmic form, y equals log base b of x, and then we have an exponential form, b to the y equals x. But both of these two things mean exactly the same thing. Okay, it's just the logarithmic function is a way to write an exponent. Okay, so the first thing that you're going to have to be able to do is convert between those two forms. So if you have something that's in logarithmic form, they're going to ask you to write it in its equivalent exponential form. So we have log base 4 of 16 equals 2. Okay, so if we compare this to what I have up here, your base in your logarithmic function will always be the base in your exponential. Okay, so that means I would have a base of 4. Whatever your logarithmic portion is equal to, this is always going to be your exponent in your exponential form. Okay, so that means 4 to the second power will always equal what your argument is here. Okay, equals 16. So these two statements would be equivalent. 4 to the second power is the same. 4 to the second power equals 16 is the same thing as saying the log of base 4 of 16 is equal to 2. Okay, so let's look at the number 2. If I want to convert this from logarithmic form to exponential, the base is 4. So I would say 4 raised to whatever it's equal to here is always going to be your exponent, is equal to the argument, equal to x. Okay, I don't want you to solve or simplify any further when it just says to convert. That's simply all that they're asking you to do. Okay, so number 3, log base b of 64 equals 2. So again, my base is b raised to the second power equals the argument, 64. b squared equals 64. Okay, on 4 through 7, we're going in the opposite direction. It says write the equation in its equivalent logarithmic form. Okay, so I have 6 to the third power equals 216. Okay, again, this is my base of my exponential, so that will be the base of my logarithmic function. So it will be log base 6. Remember, we said the exponent is always what it's equal to. So it's the log base 6 of 216, that's my argument, equals 3. So that would be our equivalent logarithmic form. Okay, on number 5, 2 to the third equals x. So I would have my base is 2, so log base 2 of x is equal to the exponent. Okay, is equal to 3. When you have radicals, it'll help you if you remember that I can convert between a rational exponent and a radical form. This is the same thing as saying 343 raised to the 1/3 power, okay, if it's under the cube root. So again, log, my base is 343 of 7 is equal to 1/3. Always equal to your exponent here, which is 1/3. Okay, again, think about if we have 2 to the negative 2 power, you know, that's still just your exponent. We would say the log of base 2 of 1/3 1/4 is equal to -2. Okay, on 8 through 10, they're actually asking you to evaluate the expression without using a calculator. You do have the log functions available to you on the calculator, which we'll talk about later on. So if I'm looking at this, it says to evaluate log base 2 of 4. Okay, here's what I need to be thinking, that this is equivalent to an exponent. Okay, so I need to be asking myself, 2 to what power? Okay, let's say we don't know, they'll say this is equal to x. 2 to some power is equal to 4. Well, what would that power be? Okay, so that power would have to be 2. So we would say that the log base 2 of 4 equals 2, because 2 to the second power is 4. Okay, if I have log base 10 of 10, what is that equal to? Okay, so I would be thinking to myself, 10, this 10, to some power equals this 10. What would that power be? 1. Okay, anytime your base is equal to your argument, it's always going to equal 1. Okay, that's a property we'll talk about in just a minute. Okay, so again, log base 3 of the square root of 3, 3 to what power would equal the square root of 3? Think about rational exponents again. If you see a radical or a square root, that would be the same thing as 3 to the 1/2 power. So 3 to what power would equal 3 to the 1/2? Well, 1/2. Okay, so you'll just simplify if the problems say evaluate. You'll convert and not simplify if you're just changing between the two different forms.